Hello everyone, this video is about an example about Chapter 6, Sampling Distributions. As we know from Chapter 6, how we can apply the concept in Chapter 6 to solve practical problems. For the variable x bar, which is the sample mean variable from the sampling distribution, if it's higher than a number, we can use the z-score formula, that is minus mean divided by the standard deviation. From central limit theorem, the standard deviation will be sigma divided by square root of n, and sigma is the population standard deviation. And similarly, if x bar is smaller than a number, we also can use the z-score formula to find out the z-score. And similarly, for between a and b, we can also use each side minus mu and divided by sigma divided by square root of n. So we can calculate all the z-scores, and we use the z-table to find out probabilities. Now here is an example about Chapter 6. A manufacturer of automobile batteries claimed that the distribution of lengths of the life of its best battery has a mean of 54 months and a standard deviation of 6 months. Suppose a customer group decides to check the claim by purchasing a sample of 50 of batteries and subjecting them to test that estimation that the battery's life. Question A. Assume that the manufacturer's claim is true. Describe the sampling distribution of the mean lifetime of a sample of 50 batteries. And the sample size here is 50, more than 30. Now we can use the central limit theorem. From the central limit theorem, it says the sampling distribution of the mean will be normally distributed. So it will be a normal distribution with mean will equals to mu. So the mean is 54 months. And standard deviation from the central limit theorem, the result is sigma divided by square root of n. Sigma is 6. N is 50. So you can calculate the standard deviation of the normal distribution, 0.85. So now let's see question B. Assume that the manufacturer's claim is true. What's the probability that the customer group's sample has a mean life of 52 or fewer months? That is asking you about the sample mean, x bar, smaller or equal to 52. So we can apply the applications. Each side minus mu and divided by sigma divided by square root of n. So in this question, mu is 54. Sigma of the population is 6. And n is 50. So you can calculate the z-score. Use your calculator. The z-score, it will be negative 2.36. So smaller than a z-score. We draw a curve and highlight the area. So it will be everything on the left, smaller. And from Chapter 5, we know this small area, it should be 0.5 minus the table value of this area. So it will be 0.5 minus the table value. Use the z-table according to a z-score 2.36, and you will find out the probability. Now let's see one more. Question C. Assume that the manufacturer's claim is true. What is the probability that the customer group sample has a mean life between 50 months and 53 months? That is the x bar between 50 and 53. So we will use the applications. Each side minus mu and divided by sigma divided by square root of n. So we can calculate the z-score. That is, mu is 54. Sigma is 6. N is 50. So we can calculate the z-score. And after that, draw a curve and highlight the area. So it will be between negative 4.71 from here to negative 1.18. So from chapter 5, materials, it should be the two table value minus. However, you may notice 4.71 in our z table. We don't have this number. It is out of the chart. And this tiny little area actually is almost 0. So we can either use the biggest number in our table, 3.09 instead, or you can just ignore this area, just shade everything. So the shade area will be 0.5 minus the table value. So this is the table value according to 1.18. So the result will be 0.5 minus 0.3810. So this is the table value according to this z-score. And you can find out the result. Around 11.9% of the chance that the customer group sample has a mean life between 50 months and 53 months. That's all for this video.